Okay, let's say we have 3 poles. Okay, 3 poles value. For example, z equal to 0 0.1, 0 0.2, and 2. Okay, so basically, if we have 3 poles, definitely we have more than 3 ROC. Okay, why? Okay, so let's draw. We have real, we have imaginary. So first circle is for 0 0.1. Second circle is for pole 0 0.2. Third circle is for 2. So if you look at this illustration, we know that your ROC, you're gonna have 4 ROC. Okay, remember back your definition. Okay, so right-sided region is actually outside outermost pole. So if you look here, your outside outermost pole is the region is from modulo z is greater than 2. Okay, for left-sided region, it is inside innermost pole. So basically, we have z less than 0 0.1. Okay, so what happens if you have another 2 poles? Okay, which is 0 0.1, 0 0.2, and 2. What happened in between? Okay, so you cannot put two-sided region. Two-sided region is from 0 0.1 until 2. Okay, this is wrong. Okay, so what you have to do is, this part you need to separate it. Okay, meaning that for ROC, it cannot consist another poles inside the region. Okay, so what happened for this part, we're going to have two-sided region. Okay, we're going to have two-sided region. One two-sided is in between 0 0.1 and 0 0.2. Another two-sided region is in between 0 0.2 and 2. So basically, this is your ROC. Okay, so we have 4 ROC. So what happened to the function? Okay, so for the function part, okay, for example, for right-sided region. Okay, for right-sided region, all your poles will approach to right, so you don't have to worry anything. But for left-sided region also, all the poles will approach to left. Again, you don't have to worry. Okay, so left-sided region is represented by minus u, minus m, minus 1. Okay, right-sided region is represented by un. Okay, so now this is another heading. Okay, what happened for two-sided? Okay, for two-sided, it is a little bit tricky. Okay, let's start for two-sided region in between 0 0.1 and 0 0.2. So 0 0.1 and 0 0.2 is your region. This is your region. Okay, this is your region between 0 0.1 and 0 0.2. So for this part, okay, let me draw back. Okay, so this is your region. Okay, so listen carefully. Innermost pole will approach to right with the function of un. Outermost pole will approach to left. What happened to 2? Okay, so 2 is outside outermost pole. So basically outside outermost pole will approach to left also. Okay, this is for 0.1 to 0.2. Okay, so what happened if we have this one, in between 0.2 and 2? So we have 0.1, 0.2, and 2. Okay. So basically it is at this between 0.2 and 2. Again, innermost pole. Okay, 0.2 is your innermost pole. 2 is your outermost pole. So 0.2 will approach to right. 2 will approach to left. Since 2 is outermost pole. So what happened to 0.1? 0.1 is inside innermost pole. So inside innermost pole also will approach to right. So the function is un. Okay? Okay, next I'm going to show you what happens if you have 4 poles. Okay, for example, we have z equal to 0.1, 0.2, 2, and 3. So we have 4 poles. Okay, so when you have 4 poles, definitely you're going to have how many ROC? So is it 4 or 5? So the answer is you're gonna have 5 ROC. Okay, why we have 5 ROC? Okay, I'm going to show you. Okay, so first circle is 0.1. Second circle is 0.2. Third circle is 2. Circle number 4 is 3. Okay, so for you to determine your ROC, definitely you have to remember the definition. Okay, right-sided is outside the region outside outermost pole. So right-sided is z modulus z greater than 3. For left-sided is region inside innermost pole. So inside means modulus z less than 0.1. But for two-sided, we're going to have 3 ROC. Okay, so we have 3 ROC. Okay, one is in between 0.1 and 2. Okay, next it is in between 0.2 and 2. Another one is in between 2 and 3. Okay, so basically why we have 3 two-sided? Because of inside one region we cannot have another poles. Means go back to the definition of two-sided. Two-sided is the region in between two poles. So basically in between two poles we cannot have another poles inside the two poles. That's why we have separated two-sided. To represent that, inside for two-sided region, inside the region we cannot have another poles. Understand? Okay, so now we're going to look for the function. Okay, so let's move to right-sided. Okay, so right-sided is very easy. All the poles will approach to right. So the function is un. Very easy for right-sided. Same goes for two-sided. For left-sided. Left-sided means all your poles will approach to left. So the function is minus u minus n minus 1. Okay, so what happens if you have two-sided here? Okay, we have three two-sided, right? So basically it's different. Okay, let's look for two-sided in between 0.1 and 0.2. So again, innermost pole will approach to right. Outermost pole will approach to, I put it here, yeah, left. So the function is minus u minus n minus 1. What happened to 2 and 3? 2 and 3 is outside outermost pole. So all is approaching to left. Okay, next. Okay, for this one, in between 0.2 and 2. So in between 0.2 and 2 here. Same goes to here. Okay, so I draw it back. 2 and 3. 0.1, 0.2, 2 and 3. Okay, so 0.2 and 2 at this part. So innermost pole will approach to right. 2 is your outermost pole, will approach to left. 3 also is outside outermost pole, will approach to left. How about 0.1? 0.1 is inside innermost pole, so it is approach to right. Okay, so what happened to 2 and 3? 2 is your innermost pole, 3 is your outermost pole. So we have 0.1, 0.2, 2 and 3. So 2 and 3. Okay, so your innermost pole is 2, so approach to right. Outermost pole is 3, so approach to left. 0.1 and 0.2 is inside innermost pole, so it will approach to right. Done for 4 poles.